Welcome to the video on solving quadratic functions and discriminants. So we'll start out with the ways to solve quadratic functions. So the solutions can be referred to as solutions, roots, or zeros. So if you have a quadratic function, your solution is where your function is hitting the x-axis. So these would be your solutions. You can find your solutions using graphing with technology and finding your zeros. You can factor, you can complete the square, or you can use the quadratic formula. So the first way to solve a quadratic is by factoring. So you start by factoring out the greatest common factor. So if we had the equation 2x squared plus 18 as our f of x, then we'd factor out a 2 from this. 2 times x squared plus 9. So we need to find what multiplies to a times c and adds to b. So we'll draw our box. We'll put our ax squared in the first box. So we'll use our factored form here, the form where we've pulled out the 2. So we'd have x squared, and then our c value is 9. So it needs to multiply to 1 times 9. So it needs to multiply to 9. And then it needs to add to our b value. So our b value is the one before the x. There is no x value here, so our b value that it needs to add to is 0. So if we have -3 and +3. So we're going to put those numbers where these blanks are. So we'll have -3x and +3x. And then we pull out a greatest common factor from each row and column. So the greatest common factor here is x. Greatest common factor here is -3. And then we have another x and then a +3. So in factored form, it would be 2 times x minus 3 times x plus 3. So there's your f of x in factored form. And then you find your solution by figuring out when that equals 0. So 0 equals 2 times x minus 3 times x plus 3. Since they're being multiplied, if any factor equals 0, then the whole thing will equal 0. So we want x minus 3 to equal 0 or x plus 3 to equal 0. And x plus 3 equals 0. So we'll solve for x by adding 3 to each side here. So we get x equals 3. And here we'll subtract 3 from each side. And we get x equals -3. So our solutions would be x equals 3 or x equals -3. So next we have completing the square. To complete the square, you would set your equation equal to 0 and subtract c to the other side. So I'll create an example problem here. So we have 2x squared minus 3x plus 4 is our f of x. So our solution to this, we'd set it equal to 0. So 2x squared minus 3x plus 4 equals 0. And then we'll subtract c to the other side. So we'll subtract 4. So we get 2x squared minus 3x equals -4. Then we'll factor out the a term from the x squared and x terms. So we'll factor out the 2. So we get 2 times x squared minus 3/2 x equals -4. And then we'll divide both sides by that value. So we'll divide both sides by 2. So we get x squared minus 3/2 x equals -2. Then we'll divide the new b value, so in this case it'll be our -3/2, by 2 and add that squared to both sides for a perfect square trinomial. So we'll go up this way. So our new b value is -3/2. If we divide that by 2, we'll get -3/4. So we'll do x squared minus 3/2 x plus -3/4 squared equals our -2 plus -3/4 squared. So we added that same value to both sides to keep them equal to each other. So that's x squared minus 3/2 x plus -3/4 squared equals -2 plus 3 squared is 9, 4 squared is 16. And since we have a perfect square trinomial on the left side, it will now become x minus our 3/4, so that's where these come from, squared equals negative 2 is negative 32/16, so this will equal negative 23/16. And then to solve it, you would take the square root of both sides. So you'd have x minus 3/4 equals, and then you can't forget your plus or minus, the square root of negative 23/16, and then you'd add 3/4 to both sides. So x equals 3/4 plus or minus the square root of negative 23/16. So this would be your solution. You could pull the negative out by turning it into an I and then a positive. So for this one, you would have two imaginary solutions because you had a negative square root. But that would be your solution. And that's how you would complete the square. So next we have the quadratic formula. It's this long formula here. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So there's a song on YouTube that you can listen to where they sing the quadratic formula. It's to the tune of Pop Goes the Weasel. So for this one, you would just plug in the a, b, and c values and then solve. So if we had, for example, x squared minus 3x minus 8, we would figure out what our a, b, and c values are. So a would be our value before our x squared. Since there's nothing there, that means it's 1. B is negative 3, and c is negative 8. So x will equal negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times negative 8 all over 2 times 1. So this negative 3 becomes 3 plus or minus the square root. Negative 3 squared is 9. Negative 4 times 1 is negative 4 times negative 8 is positive 32 all over 2 times 1, so over 2, which equals 3 plus or minus the square root of 9 plus 32, which is 41 over 2. So x equals 3 plus or minus the square root of 41 over 2. So here we have some practice problems for each of the different methods for solving the equations. So for this first one, we'll pull out our greatest common factor, which would be a 2. So this equals 2 times 3x squared plus 8x minus 3. So now we'll draw our box. Our a squared value is our 3x squared. Our c value is negative 3. So we need something that multiplies to 3 times negative 3. So it needs to multiply to negative 9 and add to our b value, which is 8. So we'd have a positive 9x and a negative 1x. So we can pull out our greatest common factors now. So we have 3x, negative 1, x, and 3. So this becomes 2 times x plus 3 times 3x minus 1. And we want to see when that equals 0. So that'll be when this equals 0 or when this equals 0. So x plus 3 equals 0 or 3x minus 1 equals 0. So we'll subtract 3 from each side here to get that x equals negative 3. Here we'll subtract 1 and we get 3x equals negative 1. And then we'll divide by 3 to get x equals negative 1/3. So our solutions to the first one are x equals negative 3 and x equals negative 1/3. For the second one, we're going to solve by completing the square. So we'll set it equal to 0. We'll subtract our c value from each side. So we get negative 4 equals 3x squared minus 6x. We'll pull our greatest common factor out of the right side. So we get negative 4 equals 3 times x squared minus 2x. Then we'll divide both sides by 3. So negative 4 thirds equals x squared minus 2x. So we need to complete the square. So we'll take our b value divided by 2, so negative 1, and square that. So negative 1 squared is 1, so we'll add that to both sides. So plus 1 to each side. So 1 minus 4 thirds is negative 1 third equals, and now this becomes x minus 1 squared. And that's because it's our b value divided by 2. Then we'll take the square root of both sides, and we get the square root of negative 1 third plus or minus that equals x minus 1. And if we add 1 to each side, we get 1 plus or minus the square root of negative 1 third equals x. So that is 1 plus or minus I times the square root of 1 third is our x value. So that's our solution. And this is two imaginary solutions. Finally, we have to solve with the quadratic formula. So here our a value is 2, b is 3, and c is negative 2. So we have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that's negative 3 plus or minus the square root. 3 squared is 9. We've got two negatives, so it's going to be plus 4 times 2 is 8 times 2 is 16, all over 2 times 2, which is 4, which equals negative 3 plus or minus the square root of 25 over 4, which is negative 3 plus or minus 5 over 4. So our negative 3 plus 5 gives us 2 over 4, so that's 1/2. And then our negative 3 minus 5 is negative 8 over 4, which is negative 2. So those are our two solutions. Next, we'll learn about a discriminant. So the discriminant is the value found inside the square root from the quadratic formula. So it's your b squared minus 4ac. If that value is greater than 0, you'll have two real roots because you'll have plus or minus the square root, and it'll be plus or minus some positive number, giving you two real roots. If your determinant is equal to 0, you'll have one real root because it'll be plus or minus 0, which is only giving you one option for your answer. And finally, if your determinant is less than 0, like it's been in some of the previous problems, you'll have 0 real roots because the square root of a negative number will give you the imaginary number. So here we have our first IB practice question, which is no calculator. It says, for the equation f of x equals 4kx squared plus 3x plus k, what values of k will give two real solutions? So we can figure out when we'll have two solutions by solving for our discriminant. So our discriminant is b squared minus 4ac, and we'll have two solutions if that is greater than 0. So here our b value is 3, so 3 squared minus 4 times a, which is 4k, times c, which is k, and that needs to be greater than 0. So we have 3 squared, which is 9, minus 4 times 4k times k, which will give you 16k squared. Has to be greater than 0. We'll then subtract 9 from both sides. So we get negative 16k squared is greater than negative 9. And then we'll divide by negative 16. So we get k squared is less than, because we're dividing by a negative, we have to switch our sign from greater than to less than. So k squared is less than 9 over 16. Then we'll take the square root of both sides, which will give us that k is less than 3/4. And also, we need our negative version because this will be plus or minus. So k is also going to be greater than negative 3/4 because you have to flip your sign because it switched to negative. So on a number line, if we add our negative 3/4 and positive 3/4, k would be between these values to have two real solutions. So negative 3/4 is less than k is less than 3/4. Now we have our second IB practice question, which is also no calculator. It says a quadratic equation has a line of symmetry at x equals 3 and a y-intercept at 0, 1. Find the values of a and b in the following equation. F of x equals a times x minus 1 times x minus b. So I'll start by drawing a picture. It says we have a line of symmetry at x equals 3. So we'll label these 1, 2, 3, 4. So our line of symmetry is here. It also says we have a y-intercept at 0, 1. So 1, 2, 3. So our y-intercept is here. So this is 3 from our line of symmetry. So if we move 3 the other direction, we'll have another value at 1. From this factored form, if this equals 0, then our y value will be 0. So x minus 1 equals 0. If we add 1 to each side, we get that x equals 1. So if x equals 1, y equals 0. So we'll have a point here, which we can also reflect across our line of symmetry to get a second point at 5. Because our 0 is at 5, we know this b value needs to be 5 so that we have an x minus 5. So we have f of x equals a times x minus 1 times x minus 5. So to find this a value, we can plug in values for x and y. So we'll start by plugging in 0 for x. And if we plug in 0 for x, we should get 1 for y. So 1 equals a times 0 minus 1 times 0 minus 5. So 1 equals a times negative 1 times negative 5. So 1 equals 5a. And then if we divide by 5, we get that a equals 1/5. So now we've solved both of our values. We have a equals 1/5 and b equals 5. So there's our solution to our IB practice question 2. So in summary, quadratic equations can be solved using factoring, where you set 0 equal to a times x minus p times x minus q. You can complete the square, where negative k equals a times x minus h squared. Or you can use the quadratic formula, where x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Your discriminant will show you how many solutions your quadratic equation will have. So your discriminant equals b minus 4ac, which is your radicand from your quadratic formula. If your discriminant is greater than 0, you'll have 2 real roots. If your discriminant is equal to 0, you'll have 1 real root. And if your discriminant is less than 0, you won't have any real roots because you'll have 2 imaginary roots. That's all for this video. Thank you for watching.